predict the climate a century into the future.
So are you getting a stereo 3D
Tom
effect?
Wigley is one of NCAR's climatologists. Wearing special 3D goggles, Wigley and colleagues can look at models of possible future climates.
Cloud ice, and the colored surface in the center is a relative vorticity, and it's being colored by temperature. So we have an isosurface of vorticity and then temperature colored on top of it.
The pictures on the screen are conjured up by supercomputers. These high-tech crystal balls offer the only means of thinking through the climate consequences of a world in which CO2 levels are double or triple what they are today.
This one, I think it's 36 by 92.
A climate model starts by trying to capture all the many factors, natural and human, which can affect or force the climate system, either trapping or reflecting energy.
There are really three categories of factor that one has to consider. One is the influence of human activities, the buildup of carbon dioxide in the atmosphere and other greenhouse gases, and also the effect of sulfate aerosols. Aerosols are very small droplets that are primarily made of sulfuric acid or ammonium sulfate that are suspended in the air, and they arise from fossil fuel combustion, and those particles have a cooling effect. The next important issue is, what about natural external factors that might cause temperature to change on a global basis? We know from satellite measurements that the sun changes on a decadal timescale. The other external influence is the effect of volcanic eruptions, and a prime example there was Mount Pinatubo that erupted and caused, for a year or two, a substantial amount of cooling. In addition, there are other interactions that are going on purely internally within the climate system. As the amount of heat in the atmosphere is transferred to ice masses or to the ocean, that could cause, for example, the globe to warm by 1 or 2/10 of a degree, or cool by 1 or 2/10 of a degree over a 100-year period.
The many processes which push and pull the climate system are fed into the supercomputers.
You can also see this kind of diurnal cycle.
Then things get even more complicated.
Between the day and night. It's a little more obvious.
The climate's ultimate response depends on a complicated chain of feedbacks
This is even better than the satellite, isn't it?
that can either amplify or diminish the original warming or cooling.
We're at the point now where the amount of carbon dioxide is roughly double the present level. And if we were to add carbon dioxide to the Earth's atmosphere and cause warming, then the oceans would warm and the amount of water evaporating from the oceans would increase. And it happens that water vapor is also a powerful greenhouse gas, so that by putting carbon dioxide into the atmosphere, we increase the amount of water vapor, and so we increase the total amount of greenhouse gases in the atmosphere and amplify the effect of carbon dioxide alone.
Here's a straightforward example. You first warm the climate for whatever reason, and then the chain is snow and ice melt, a darker surface is exposed, that darker surface absorbs more sunlight than did the snow and ice that was there before, and therefore the climate warms even more. It's a positive feedback. It's as though you had the thermostat in your house set so that when the house warmed up, it turned on the furnace and warmed it up still more.
But some feedbacks, like clouds, are even more complex.
If a low-level cloud is generated, then that shields the surface from the sun so that you get less solar radiation arriving at the Earth's surface. So that's a negative feedback. However, if you generate more high clouds, then those higher clouds can actually help to trap the infrared radiation leaving from the surface and warm up the system.
NCAR is just one of a dozen scientific groups who have tried to incorporate all these feedbacks into their computer models. Under pressure from policymakers, they have tried to predict what will happen to the Earth's climate when CO2 doubles in the atmosphere. All the models predict the Earth will warm. But the wide range of predicted temperature increases has drawn criticism from greenhouse skeptics.
These models are all produced by very competent people, excellent meteorologists, fantastic computers, Why do they not agree? Why do some models predict a warming for a doubling of CO2 of, let's say, 5 degrees centigrade, which is 8 degrees Fahrenheit, and why do other models predict something like 1 degree?
The different predictions reflect real gaps in knowledge about the Earth's climate. If the water vapor and cloud feedbacks are strongly positive, as some modelers assert, then a huge change of up to 8 degrees Fahrenheit is to be expected. If this feedback is weak, as some skeptics argue, then a rise of only a degree or so will occur.
If you didn't amplify what CO2 did with having water vapor and clouds go along with it, you'd only at most get a degree or so.
With a doubling?
With a doubling. And tripling would not do much more. And people have pretty much accepted this would not be a major change in the world as we know it.
The computer models tell of possible futures, some scary, some less so. Which is true? Currently, there's no way to know.
Computer models of climate are the most complicated, ingenious computer systems I've ever seen. I mean, they really are good. But in the end, you have to just face the fact that they are not going to be able to give you precise, certain answers. They're going to give you, we think this is what's going to happen, and here's the limits of error. And that's the uncertainty, and you have to choose.
If the scientists are uncertain about the precise global temperature increases, they know even less about the specific effects the warming will produce. Of greatest concern is sea level rise caused by melting glaciers and thermal expansion of warmer water. Coastal areas from Venice to California would then be vulnerable.
Off the coast of California during El Nino events, the sea level rises, and in the last El Nino event it was about 8 inches above the normal value, and what we saw was a lot of coastal erosion, houses toppling into the sea. And so that's sort of an indication as to what increases in sea level can do. We can adapt to a climate change as long as it occurs slowly enough. But if it occurs too rapidly, then it disrupts the assumptions that we've built into the way in which society works, whether we're planning agriculture, whether we're planning a building with its heating requirements, whether we're planning a dam.
If such human-induced climate effects occur, rich nations may be able to adapt and build seawalls. But for some countries, this isn't an option, like the 1,200 low-lying Maldive Islands isolated in the Indian Ocean.
All of these islands are totally flat. The average height above sea level is about 1 meter, and they are totally exposed to the sea. If there is even a minute change in the level of the sea, or a change in the size of the waves that come into our shores because of increased incidence of hurricanes, typhoons, we are all dead. The impact of global warming and climate change can effectively kill us off, make us refugees, lose every bit of land that we have available to us right now.
But greenhouse skeptics think such scenarios are alarmist. Modest warming, they argue, may even be good.
We have to ask, what are the impacts of a warmer climate? What is the impact on agriculture? The answer is it's positive, it's good. What's the impact on forests of greater levels of CO2 and greater temperatures? It's good. What is the impact on water supplies? It's neutral. What is the impact on recreation? It's mixed. You get, on the one hand, perhaps less skiing. On the other hand, you get more sunshine and maybe better beach weather. Let's face it, people like warmer climates. There's a good reason why much of the US population is moving into the Sun Belt, and not just people who are retiring.
But most climate scientists are less optimistic.
We're talking about humans modifying the climate so that if we're lucky, we only get another degree in the next century. And it could be several degrees per century as our best guess. compare that to the degree per millennium of history, and now ask one more factor. How are the species of trees, for example, and birds and so forth, how are they going to migrate? In history, they just migrated. Now they have to cross factories, farms, freeways, and urban settlements. So if you have the combination of fragmented habitats with nature getting into smaller and smaller patches, now you change the climate 10 times faster than the history for which they have experience, this seems to me an absolute prescription for an extinction crisis.
And some scientists caution there's a possibility that even modest warming might trigger major climatic changes by destabilizing the currents of the oceans. The oceans are the wild card in the climate system. By carrying warm water from the equator to the North Atlantic, currents like the Gulf Stream have a tremendous impact on the Earth's climate. By the time the Gulf Stream has reached the North Atlantic, the water has given up its heat. The now cold and salty water is so heavy it sinks to the bottom and returns to the equator to form a closed circulation.
These circulations are responsible for taking water from the top of the ocean down to deep levels in the ocean, in some cases right to the bottom. In doing so, in the present circumstances, this is a way of getting heat into the ocean and also a way of getting carbon dioxide buried in the deep ocean. So it's doubly important, this circulation, for the climate issue.
But for this, the climate in Europe would be very different.
Think of the climate in the British Isles or in southern Norway. It's a mild climate. You can play golf in Scotland in January. But what's the latitude of northern Scotland? I mean, bring it over to the United States and you're sitting in the middle of Hudson's Bay.
What worries some scientists is that in the past, this circulation appears to have stopped. A close examination of polar ice cores reveals about 10,000 years ago, while the Earth warmed up from the last ice age, the climate suddenly switched back into a cold state. Temperatures fell nearly 10 degrees in a decade. Some scientists believe it was caused when fresh water from melting glaciers flowed into the North Atlantic and disrupted the ocean circulation. What might happen if today's global warming caused the circulation to stop?
First, the North Atlantic would get much colder than it is today. That would mean northern Europe would cool down very rapidly. If that kept up over time, one would get more and more snowfall over time. And one of the hypotheses for going into an ice age is a shutdown of just that circulation, leading to more and more snowfall. Then it accumulates, it lasts over the summer, and steadily over hundreds, thousands of years, you can build up glaciers on land that was previously vegetation covered. Paradoxically, a warming in that case would be leading to a catastrophic cooling of some parts of the world.
The mighty oceans, some scientists argue, are the biggest uncertainty in the climate system, capable of dramatic climate surprises.